Discussed last time various topics which were related to cloud computing. Now this time we'll go further and we'll discuss various architectural concepts which will be around cloud native development. We also discussed a little bit about cloud native development as well last time, and we'll take over from there and we'll go through various concepts. And this time I'll give you a lot of some tasks, small mini tasks, so that you can also do some research and know more details about the topics which we are learning. So we discussed last time that there are different cloud computing models, right? So I guess you all would have been remembering that various cloud computing models which we discussed where we discussed private cloud. These are cloud computing models based on the deployment. We discussed about public cloud. We discussed about hybrid cloud, right? So everyone clear with the differences between these three types of clouds? So can someone find out some examples of hybrid clouds? What are hybrid clouds? And then I also got to know recently there is also fourth model, which is something called community cloud. So these are now four different types of deployments which are used in cloud. So any inputs on this? Anything? Anyone have examples on hybrid cloud?
Yeah, in that case, the company will have own data center,
Yes.
and they are also using public cloud, and then the public cloud to data center they are connecting with the some direct connection or some hosting connection will be there, and they will create they might be connecting to the VPN. Okay. So that way the hybrid model works.
Yes, perfect. Okay, great. And anyone have idea about community cloud? This is something, the fourth categorization.
Yes, we can guess it that, but I don't think so that it's maybe correct.
Okay, just go ahead.
Yeah, might be that some of the company having their own data center, and that data company has created that data center. That data center can be used by the multiple organizations, and then they are using the public cloud. So that's way, and then through the VPN they are connecting to their organizations. That way I can say it. So
Community cloud is a cloud where multiple organizations can connect, and they may have some same mission and same goal. The cloud is for usage of a community. It's not just one organization, it could be multiple organizations. I'll give one. I don't have exact example at the moment, but you can think of GitHub as a community cloud. It's a community. Assume there is a project which is working, for example the Java project. So there is a community of Java developers who will be working on updating the Java platform. So that could be a kind of a community cloud where you are sharing resources, and maybe there are servers, test systems, which is available for all the Java developer community, which includes various organizations and individuals who are working on Java development, right? So this is one example of community cloud. There could be industry specific examples where in pharmacy industry, or for example NASA may want to work with various other organizations like ISRO and various other space research organizations, and they can create a collaborative cloud which is only accessible to community of researchers. So these are examples of community cloud. So that's the fourth deployment model which I wanted to discuss. Let me share my screen, because then I'll present my slides as well. So my screen will get shared in few minutes. Yes, now it should be shared. And just a minute, I will switch to yeah. So the other terms which we wanted to discuss is about the infrastructure as code. So who would like to take about this topic? What is infrastructure as code?
Yeah, infrastructure as code, like provisioning of the resources by writing the code that you can use it, and then you can do the deployment related activities. You can write the code, and then you do all deployment related activities through this infrastructure code. So there are multiple examples that we were using the earlier days, like Ceph, Puppet, or Ansible. We are using it. That way we can do it. But right now, nowadays, that the Terraform and CloudFormation has come into pictures. So that's I can say.
Yes, yes, right. Perfect. So I'll give you what is infrastructure as code. This is a new methodology of creating your infrastructure so that it can be replicated. So one of the most important characteristics of cloud computing is that you should be able to scale your application, and you should be able to deploy your code into multiple data centers across the globe. So for example, when I was working with Office 365, there were around 250 data centers where any changes, any code which I make get used to get deployed. So, and with time, there were new regions where more data centers were opening up. So it becomes very important that as new data centers are opening up, the infrastructure could be created very fast and in a very efficient manner and without any errors, and all the configurations are replicated as it is. So earlier, the way it used to happen was there used to be instruction set, right? So you can have a setup guide and share the setup guide, correct? So what's the difference between these two approach? Which one we should prefer? Sharing a document which has the instructions setup guide, or having infrastructure as code? What is the benefit and disadvantages of each of these approach? So Madhu, can you take up this?
Which two examples you told that okay, what is the difference, and
Yes. So
what is the infrastructure as code, and second which one?
Second is I give a document, right? So the other option is I can give a setup guide and give it to administrators and ask them that, okay, assume I am a developer who is working on, say, Word Online or Google Docs, right?
Okay.
Now, for running Google Docs, there is a set of infrastructure which is required. Tomorrow, assume there is a new data center which is getting opened up in some remote location. Say it's getting opened in maybe Mumbai. There is a new data center which is coming up. So to set up the infrastructure for Google Docs, there are two things I can do. I can give the admins the document saying that this is what I need to have my application running. Please set up this. Or I can use some provisioning like infrastructure as code. So what is the advantage, disadvantage of both these approaches?
Yeah, first approach, once I am seeing that it is a document. That document I need to follow it. That is that shows that it is a manual interventions I need to do it.
Yes.
Okay. And the second approach, I see that okay, I have yes, I have written a code. That code has to be run, and that code can provision the infrastructures without any interruptions.
Right.
Okay.
Right. Correct.
What I see that okay, if something has to be do first approach, if I have to do something manually, some some verification if some line if I missed it. It is a
Yes.
manual error, and then it will create a lots of kiosk, and then we cannot, and then we have to go by the each steps from the from the beginning. That's why that it's create a problem.
Yes.
Okay.
Yes.
But
Definitely.
once you are, and then here once one more issue comes at the verification testing of testing of your infrastructures, means what all infrastructures has provision or not, that you cannot do it from writing the code. Here is a manual documentation, and you have to do it by your own. But here in the infrastructures, the code at the you want to test the infrastructures of the all the resources. So it is the test part you have written it, and that is you created the automated testing, and that automated testing will tell you that okay, what all issues is coming in, and it will let you know that okay, this issues has come, and then you can go and you can verify that the verify the infrastructures, what that I can say.
Yes. Right. Correct. So Sampath, are you using infrastructure as code? Your inputs on this?
Yeah, Tarun. So we actually use the Kubernetes for orchestrating the number of pods. So
Okay.
and our applications are like all our cloud native applications only, so that we can scale up automatically whenever we require. So there are some auto scaling groups we have defined it. So based on the load, that will kick in and it will start the new pods also.
Okay. Perfect. So yeah. So but you are not so for example, when your pods, Kubernetes clusters, they are running on some hardware, physical hardware, which
Yes.
will be in any cloud
Yeah,
environment
AWS.
in AWS. So
Yeah.
how are the so for example, they may be running on EC2s, right? Or what?
I think they are running on EKS service.
Okay, yeah, EKS, because it's Elastic Kubernetes.
Yeah,
EKS stands for Elastic, I think.
Kubernetes only, I think.
Yeah. So, how to provision that? How is it happening? How are the EKS getting reserved?
That I'm not sure how it is getting resolved it. But actually, by default, I think for each service, I think we are running around 8 parts, so that to like balance the load. That's what
Yes.
I remember. But how we are provisioning, I'm not sure how it is done.
Right. Madhup, you have any idea on this? How is the EKS could get provisioned?
Yeah, in that case, that kubectl command we need to write inside inside a script, and that kubectl will kubectl will spawn a service, spawn a pod, and then once it spawned a pod at and the what all services we have to deploy it on the this pod before terminating the pod before terminating the earlier pod. It is following the blue green approach that it is verifying the health status of the kubectl pod, and then it is removing the pod, and then what about the load balancer size at the means here the script is created for the replicas also, that okay, what should be the minimum replica should be there, that replica, and the namespace will be associated with this pod. And then what will happen that the load balancer part, that okay, what all load balancer will create it. So their services will be service will be created for this kubectl part, and that kubectls will allow that okay, which pod it should rotate it, and through the services there are the multiple component inside a kubectl inside a Kubernetes. There's one part is one part is the services. Their services we need to know that okay, this part will be routing to the which pod. That way it will works, and yeah, that I can remember.
Yes.
And and the one more thing, that the EKS is using the internally the EC2 yes underlying VM. I can say that the EKS is there, but EKS it requires some VM to deploy. It
Correct.
requires some VM to deploy it, so it will use the EC2. So that provisioning is also required. Once you writing the EKS, and you can go there inside of the AWS console, you can see that some EC2 is also running there.
Yes, right. So see, here there is only very small picture of the application, because when you provision an application and it's an end-to-end application, assume, then you will have a web server, you will have the databases as well, and you have various application servers, and so you'll have the complete configuration, and you may need run some of them in Kubernetes, some may be some external services also which could be running on some other infrastructure. Say for example, take an example that there is AWS Lambda, serverless there is a serverless component also which is interacting in this particular application. To set up everything, you can write another code. Have anyone worked on CloudFormation or Terraform?
Yes, I know the little bit idea about the Terraform.
Okay, just go ahead, share what is Terraform.
Terraform is what I can see that the Terraform is built by the IaC corps. Okay.
Yes.
And this IaC corp that it is actually the script. That script that we need to write that okay, what all infrastructures provision is required in that script, and that I will write that the what all infrastructures provision for this once we are going to deploy any application. So that way that I will write that different code to provision this what all services required, that I will write it. And once the authentication will happen between the two server, then in that case that it will go there and it will just provision the resources.
Yes, absolutely right. So we'll do some hands-on maybe in upcoming sessions about how to do this, and we'll see this in action, so it will be clear. So this is the idea, that you write code instead of, so there are various phases in which the same thing can happen. So assume, I will take again the example that assume we are creating a new feature in Google Doc, and we are the owner of this application Google Doc, and there is a new data center which has come recently, and we want to provision this application into the new data center. So the way, most primitive approach, very layman approach, was I share the documentation how to do it, which is a setup guide for the administrator, and there I specify this much capacity of computing resources you reserve, this is the database server requirement, this is the load balancer, etc. And I have to also share about the network connections. I have to also share about what operating systems to be installed, what JVM version has to be installed. So there will be so many different configurations. Even I have to share him what all software updates have to be installed, and what are various dependencies which are required. For example, database is one dependencies, but there could be any other dependencies as well which may be required. So this will become a very big document. Maybe it will become 100-page document, and then it will be very difficult for someone to do it, and it will take time also, because this is documented on some paper or software documentation. It's like software documentation, so there will be a lot of engineers who will be reading it and following it, and maybe some people may not be able to understand it properly. So sometimes the systems will be not available as per the expectations which I shared, and once they will deploy, my application may not run successfully, and now it will become very difficult task to troubleshoot, because there's someone else who has provisioned the system, and he has the admin right. As a developer, you generally don't have rights to provision servers on the data centers because that involves cost and all. So this becomes a very nightmare, is a kind of a nightmare to set up and work and get these new data centers provisioned. So there was another approach. Approach 2 was, instead of a document, I will set up some automation scripts. So where there will be a lot of scripts written, maybe Python scripts, or maybe it is scripts in the form of some Jenkins or scripts, or there could be various kinds of scripts which I can give. So that's another approach. There I can achieve some automation, but again I cannot do complete automation because physical hardware provisioning, reserving how many EC2, that has to be done manually. So again, no, there will be a mix of two kinds of steps. One is setting up the servers, which will be manual step, and then various installations which will be done on top of it could be automated. So this is another approach which is more of automation scripts, and these automation scripts could be for various things. First is these automation scripts could be for first time deployment. These automation scripts could also be for upgrades, and these automation scripts could also be for I would say in case of any crash, system restart or patching. So there will be different set of scripts which you have to provide for various purposes. So this is another approach, but this also do not totally avoid this situation where there could be some errors, because these scripts someone has to trigger. Sometimes it could be automatically triggered based on some events, but still you have a lot of provisioning step which happens manually, and there are chances of errors. Now the new approach is infrastructure as code in CloudFormation. So you may also graphically model what all servers you need. In the backend, it will be converted to a code, and this code is something which could be given to provisioning environment, say AWS. If I give this code to AWS, in this code there are instructions about how many EC2 servers to provision, what kind of other infrastructure, say for example in case there's serverless compute engine that has to be reserved, or API gateway have to be reserved, or load balancers or any other kind of resources have to be provisioned, that will be done automatically. So now this automates everything for cloud deployment. So this is one important phase or important I would say practice in cloud native application development. Clear?
Yes, it is clear. But one question here, Tarun comes at we were using the infrastructure as code earlier also, like in case of the Ansible, Puppet, or Safe, we are using it. But nowadays also we are using the infrastructure code in the form of Terraform. Why
Yes.
the Terraform has become so popular that what we were using
Yes.
earlier?
See, the Ansible or Puppet, these are all automation tools.
Yeah.
We'll not call them as infrastructure as code. Infrastructure as code is you define how many servers and what kind of servers, even what kind of RAM, what kind of memory storage, what kind of processors to reserve, and based on that code, that appropriate server will get reserved. This is infrastructure as code, right?
But we were using the same thing in case of the Safe also we were using it. Okay, what did you tell right now, that the same resources, what all resources get
Yes,
provisioned, that
yes.
we were writing there also
Yes.
the code.
So the other difference is in these scripts, when you write, they are specific to a platform provider, for example AWS. Now, as you mentioned already, that these new technology is from third party like HashiCorp. So they are also platform agnostic, right?
Yes.
So this is another advantage, and it simplifies provisioning. And Chef, Ansible, these are technologies which require a satellite server, right? You need a server first. You have to first have a Chef server registered. Then next what you do is you create servers which will get instrumented to talk to the chef server, and then chef server can run various automated scripts on these remote servers. So still it's little bit complicated and overhead prone, and you need additional management infrastructure as well. So this is the difference, and with Terraform it is natively supported in the cloud environment. So the web interface of AWS or Google Cloud Platform, they will have this capability to accept the Terraform code and then automatically provision the server instance based on the input which you have shared in the form of the Terraform code.
Okay.
Right? So we'll do this more practically in next session, so that you'll get to see this. But for now, you just understand that with cloud native technology, we are keeping everything as code. Your actual programming logic is code, but then your infrastructure will also be as code. Infrastructure as code does not mean you have infrastructure based on code. It means that the server provisioning or the configuration details are kept as code, and this code could be automatically executed. By code you mean configuration which could be executed.
Okay.
And this execution will result in getting the desired system environment set up as per your requirement.
Okay.
Great. So any other questions, Tashmita and Praveen? Are you able to understand this concept of infrastructure as code?
Yeah, like trying to understand a little bit.
Yeah, sure. Great.
So, what are the technologies? Like, is it like Kubernetes or any other technology do we have which will execute these instructions? Tharu?
Yeah. See, Kubernetes is the clustering, or I would say container technology.
Yes, container. It's container.
Yes. So containerization, when we'll discuss, we'll talk more about the Kubernetes. But infrastructure as code is more about provisioning the servers, provisioning the computing resources, provisioning the storage resources in the form of some scripts which are written in Terraform or CloudFormation, which is this is the most popular technology which is used for writing infrastructure as code. There are few others, but mostly the industry is towards platform agnostic technologies. So the most popular one are Terraform, because earlier there are other technologies also which were dependent on the platform provider. Say for example, when you provision some GCP, there may be some backend configuration which is generated, which you can always export, but that configuration is not platform specific, and it's also very difficult to read and maintain, because one of the important characteristic of code is it should be maintainable. So what if you generate some code which is based on your server configuration, but if it is not maintainable, it is of less use, because your infrastructure configuration you would like to modify, because as you will be adding more components in your applications, as you will be adding more features, you may be adding more microservices, and these microservices may require more servers, and then you have to modify your infrastructure as code as well. So the code which you provide should be very maintainable, and it should also be understandable, so that someone can fix problem, and when it's understandable, then only it is maintainable, and it could be automatically it could be modified also by other developers, so that they can adapt it to the changing requirements.
Okay, I'll frame my query again, Tarun. So assume that I have a Git project where I maintain this infrastructure as code. I maintain a file where I'll
Yes.
mention the configuration. Okay, now who is like how do I provide these details to cloud? Or on the cloud side, who will read these details? There should be a component on the cloud that should read and execute and provide us the infrastructure. So do we have any such component name? Or is it called Terraform? Terraform, I think it's a pattern or maybe a configuration which helps us.
Yes, right.
What is there on the AWS side or GCP?
Correct. How is it getting consumed? We'll
Yeah, yeah.
see this, as I said, in the next session, where we'll write some infrastructure as code, and then
Okay.
we'll get inside into the AWS and get this executed, and we'll see how the infrastructure is coming up.
Great, great. Thanks.
Right?
May I explain? May I explain, Tarun, here?
Sure. You can go ahead.
Yeah. See, actually, Sampath here. Once, what is happening at the suppose that you want to direct connect to the AWS console. So what you can use at the AWS CLI, you will use it. And suppose that on the what you want to provision the some of the resources onto AWS. So if you have the console is there, you can go there directly and you can create it. But from the AWS CLI also you can provision the resources. That provision of resources means that you have to write some of the command for provisioning of the resources that you have to write it. Similarly, what you have to do inside a Terraform, that whatever you using the AWS CLI command to provision the resources, that command you have to write it inside a Terraform so that it will provision the resources whatever your requirement is there. That's way it works.
Great, great. Thanks, Madhu.
Okay, yeah, very well explained. Because yes, there is multiple ways to execute the Terraform, and with the help of the command line tools also, and also with respect to the console also. And in again, Azure and in GCP, there will be different ways, both in the command line as well as in the graphical user interface. Great. So this is about infrastructure as code. Now, other thing we'll look into is, this is not about just provisioning, initial provisioning. It's also about managing your infrastructure also. That means you can modify it, and based on changing requirements and needs, you can update your infrastructure also automatically using infrastructure as code. And you use a declarative language. Do you know what is declarative language? This means that you do not worry about how to do things. You are only interested in what. So you specify. Declarative languages are languages like annotations in Java, or HTML is a declarative language, because when you say button, you don't tell how to create a button. You don't get into the details like you have to draw a square and then, or a rectangle, and then you have to create a label, and that's not declarative. If you do it that, it is not called declarative. Declarative means you just specify what you need, and the code takes care of how to do that, right? For example, in annotations, you just say overwrite, but what is the internal mechanism, we don't worry about it. So Terraform, CloudFormation, these are technologies where declarative. So you just have to write less code, and you just have to specify what you want, and you did not have to worry about how this has to be done. That will be taken care by the system. Now, the good thing is you can use version control on infrastructure as code, because with version control, if sometimes your infrastructure changes are not working as expected, you have the option to roll back, which was not there in case of manual document. So if I share some instruction set, and if some step was done wrong, there's no way to revert back to the previous state. But with respect to Terraform infrastructure as code, since it's in the version control, you can retrieve a previous version and run that again, and you should be able to get to the previous state as well. So it just not only automates the provisioning process, it also makes the infrastructure more reliable. So let's move to the next topic, which is microservices architecture. So this is a very common terminology now, but we'll go into depth of what is microservices architecture. So the microservice architecture is all about breaking up your application into smaller independent services. And the advantage of breaking up your application into smaller services is that you can scale the components individually. Right? So that is an example of microservices architecture. And very important point here to understand is that it is different from component based architecture, right? So, or modular architecture. So microservices architecture is different than modular architecture. I'll give you an example. I've worked on an application which was a kind of a content management application. So in the content management application, I had three components. One was the image server, other was the web server, and there was one more server which was running the admin module. So I have a web server which is running web applications which are user facing web applications, and then I have another server which was running applications which were specific for admins. And then I had an image server which used to store images. It used to do a lot of processing on the images, and it used to store the metadata as well in the database, and it used to optimize images, and it helps in import export of images on various web page. So this was an application which was modular application, used to talk to the database, and it used to have a load balancer, and the user can use it through various browsers, and it was using a responsive UI, and it was using all the best practices. Now this was a modular application, but this was not microservices based application, because I was still running many user facing services and admin facing services in servers. But can someone tell why this was not a microservices application? You can guess because you don't know definitely what was the application, but why it could not have been why was the case that it was not a microservice application? It could not be scaled independently. Each of the components could not be scaled. So what differentiates a component based application or modular application with microservices application?
Yes, Arun. Microservice architectures, if we are making it that yes, as you told, it should be horizontal scale on the basis of the load. Okay, it can do it.
Yeah.
Okay, but if you are making a component based architectures or modular based architectures, that it might be running into the same web server or same server. We can see the same server it is using it, and same server, and then if it is a scale if it is getting a scale means that it is getting a scale that the whole component, not the single component. So if the load will increase that, so it will scale whole component.
Correct.
So that way I can say that
in one word, to answer the same thing, in one word is, it was not loosely coupled application. It was a tightly coupled application, because my image server used to know that there is only one application server which is user facing. There's one admin server which is admin facing. So all the components, they used to know that there is something called image server, and there has to be only one instance of image server, and my database also used to know about other components. So all these details were hard coded, or I would say that they were tightly coupled applications, because every dependencies other component was aware of other component. So I could not individually scale these components, because if my number of users increases, when I increase the user component, the application architecture and design was such that I have to create one more admin component also. So this was how the design was. So it was tightly coupled, it was not loosely coupled. But if it would have been loosely coupled, that means the communication between the two servers will be through REST, right, or through some standard protocol which is generic and is not dependent on no exact addresses. So the important point is your interfaces should be generic, and they should be able to consume components or consume messages from any number of servers. Only thing which they have to just ensure is the contract or the interface definition is as per what they have agreed upon, and they should not bother about from where the message is coming. They should just accept the REST message if they have a agreement with respect to the contract. Got it? So here, microservices applications require additional security as well. You should understand, because the application is loosely coupled. You never know where the message is coming from, and same is applying for the outgoing message. You may be sending some message, and you have to just ensure that the message which is being accepted is accepted by the party which is trusted. So you need good mechanism of security in microservices application, and your application should also be reliable application, right? That means it should have fault tolerance as well, because if one component is down, it should not bring down the entire application, right? In my application, I had the three components: image server, admin server, and user server. And it was very important that to user server to run, image server should be up and running. If it goes down, the other servers also goes down, because they were tightly coupled. And if they are loosely coupled, then it can still work, because in microservices application, if one service is down, say for example, I'll give an example of Amazon application. Assume the payment server is down. So what will happen is you will not be able to pay, but it will never happen that you will not be able to browse the catalog. So you'll still be able to see the products, you will be able to see the reviews about the product. Only thing is you may not be able to do the payment, and you may not be able to place the order, but you can save the order in the shopping cart and retry after some time once the payment server is up. So this is difference between a monolithic application and microservices application. So IRCTC used to be, and there is always you can't say that some application is 100% monolithic or 100% microservices. There could be applications which have some components which are acting like monolith, and some components which are microservices based. Because in many of the applications, say for example in Uber started first as a monolithic application, and later they decided that as the complexity of application have grown, they wanted to deliver new features faster. So they started decoupling it, and they started decoupling it gradually, and new components were developed as microservices and older component were on the monolith. So for many years it was a mix, a kind of a no, mm, some components monolith and some components microservices. So here what I was talking about was that in microservices the components are loosely coupled and independent of each other, and you can scale them independently. Right? Any other points someone wants to cover?
One point I need to add that if we are making a microservice, it should be it should be domain driven. It is not like that. Okay, we can create the one microservice for one services. It should be domain defined, or it will give the loosely coupled architectures for one services for one services for one microservices. But in that case, it will give the lots of overhead also, that
Yes.
that we have to trade off between the bounded context as well as what all microservices we are creating.
Yes, yeah, very good point. That if you have too many microservices, then that's a problem. Because if assume I have a service which is, say, check the stock availability of an item in some e-commerce site, say Amazon. So when I do a availability check for an item, first thing is no, it is checked that where is the warehouse for that particular item, and then in the warehouse there will be a query which will be made, which will be how many items, what is the quantity which is available, and maybe some more details would be required at the time of availability check, that whether this particular warehouse is right now no having shipments, or no, are there some items booked, or are there some due to various other reasons like regulations and compliance, are the items in their stock shippable or not. So maybe there are multiple web services calls which have to do to figure it out whether the stock is available, and then there could be some other APIs which would give the shipping time, whether it could be delivered by Monday or by next week or by how many days. So this microservice, if we create a smaller microservices, multiple smaller microservices, so there's a lot of communication which has to happen between these microservices, and you will have a lot of performance overhead. And not only that, troubleshooting also becomes problem, because if the call fails, you're not sure what went wrong, where things went wrong, whether the warehouse stock was not returned properly, or what about the status of the item, or what about the shipment, which service failed. We are it will be difficult to figure it out, because you would need tracing all the areas. So you should have right kind of granularity, because if you have all the services in the same server, then again you are making it monolith. But if you are partitioning the microservices into smaller services and in different servers, then there's a lot of communication overhead. So one service should be capable of performing a well-defined responsibility, right? So that it should not depend on too many other things. If a service is depending on too many other things, then there is a possibility of performance bottleneck, and we should try to optimize it. So you can have in microservices architecture multiple services running on one server. That's not bad, but there should be right number of services, and the goal is you should be able to deploy and independently update one microservice without having to touch other microservices as well. This will give the speed, and each of the microservices could be taken care by one team, and that team can ensure this microservice is always up to date and is running in the efficient manner. So in microservices, you can have various services using different technologies because they are loosely coupled. They only communicate with REST. So one service could be in Java, other could be in Python, third one could be on JavaScript. You can prefer whatever technology you use, and each of the microservices also has separate database. So now most of the time microservices have separate databases, and in a component based application you may have multiple components using the same database. So that's another difference. Clear? So I hope you are now very clear with respect to microservice architecture and how is it different from the component based architecture.
Tarun, I have a doubt over here.
Sure.
Suppose if multiple services are in a component based application, if multiple services are trying to update the same record in the database, then that could be an issue, right? So
yes.
So generally, it's a quick overview. Can you guide some? Can you tell something about it? Generally, how it would be handled?
Okay. Yeah. So if you look into any of the traditional applications, say for example SAP applications or Oracle ERP application, they are having single database. Now your problem is, in a single database, if there are multiple requests coming from different components, then there could be bottleneck. So database is generally the bottleneck. How do you deal with this is you always have multiple copies of the database clusters, master slave. So you have master slave architecture where you have a master, assuming it's a read heavy database, then you may have some masters. Say for example in my case I had admin server. In an organization there may be 10 admins and there could be 1,000 end users. So in that case I have 1:100 ratio between master and how much write I want to do. Assume end users they only read and admins only write. And read and write. Write means read and write because you have to read also sometimes and then update. So I can have one master and 10 slave systems, and for reading I use the slave systems, slave databases. For writing I use the master copy always. So this is one way of handling multiple calls. So this way, depending on how many requests are there, these requests could be served by different database servers.
No. My query was actually, suppose two services are trying to update one record, not the reading up. So if two of them are trying to update a single record,
yes,
that will lead to inconsistency, right?
Yeah, so, locking is there.
Yeah, so when we are using a single database, because the request is coming from different services, that is a problem. So yeah, just worried on that.
Right. So for that, if you are writing to the same table, you would like to have a locking in place.
Okay.
So database ensures that there is lock, and before writing a request has to acquire the lock. So once the lock is acquired for a table, and different databases, they support different kinds of locking. For example, in Oracle, you can do cell level locking. In some databases like MySQL, you have only row level locking, or sometimes you may have only table level locking. More granular the locking is, more flexible you are. And in this way, you can lock the row which you are writing. So this way, two requests cannot write to the same row and there will be no inconsistency. So locking is the mechanism which is taken care by database, and as an application programmer you don't have to worry about it. It's by the design in the database that locks will be in place, and concurrency will also be handled in by the database. Because the other problem is, you may have lock, but what if two requests come exactly at the same time? Which one to be requested first? So that all things are taken care by the database, and that's why it's called ACID database. ACID means it has atomicity, because if you are updating the entire record will get updated, and if there are multiple records in the transaction, all of them either will be updated as one or none. Nothing will happen. It will not have a partial inconsistent state. That's about atomicity, consistency, integrity. Consistency is you will have consistent read and write. So when you are reading from multiple sources at multiple time, you'll always see the same data. It will not happen that no, I'm making a request to read the price of an item. I'm seeing $10, someone else seeing the same item's price as $20. So there will be consistency, which will be again ensured by the database. And then the third thing is integrity. You can have various validations in place, and then D stands for what's the D? ACID. Anyone?
Durability or?
Durability. Yeah, durability.
Okay. What is that durability? Anyone?
The state, whatever is the record state, that has to be there for permanently, I think.
Okay. Yes. Absolutely. So it should not happen that, sometimes what happens in your programming languages, you have a variable, but in C it used to happen because some other memory can override it, because there is a pointer and you use some pointer and you can manipulate. So although the variable you stored some value, say 10, but after some time having no operation on that particular variable, still the value got changed.
Yeah.
So that should not happen in a database. When I set some price as 10, it should remain intact, durable. It should be durable. It should not happen that because of some other reason, some other records were written, so this record got overwritten.
Yeah,
Right?
there are some in-memory databases. So when we restart, we lost the data. But in case of this ACID databases, it
correct.
will be remains.
Correct. So this is very important point. Yeah, durability means maybe for many years, many months, the data which is stored should remain exactly as what it was stored. Absolutely right. Great.
Thank you. Thanks, Tarun.
Yeah, one more thing I need to add at Tarun here. See, you told about the transitions, and you told about that, application programmer don't need to think about these transitions. But I knew that application programmer also need to think about this transaction related query while writing it that there are different isolation level they have to write it in the application programming. Through the optimistic locking or pessimistic locking we can write it so that it can be, if the same inventory has been acquired by the two user at the same time, so that it should be either optimistic locking or pessimistic locking. We can do it, and we can handle this transition.
Yes, definitely. So here what I mean was you have declarative way of specifying. You have to enable, disable locking, but what exact algorithm to be used, right? So if you have pessimistic locking, you need not have to write the logic for the pessimistic locking.
Correct.
So that thing is taken care by the database. So database takes care of the implementation, but yes, definitely you have to specify what you want. So you have to specify what you mean by a transaction, how to do rollback.
Okay.
But when to do the rollback, that can be determined by the database.
Right,
So
that's right.
database can determine that, okay, the transaction has failed and have to roll back. So you just have to tell that, okay, this you have to do on the rollback. So this is the difference between what is the facility provided by the database. But yes, programmer have to worry about at very high level for all these things. They do not have to worry about at the implementation level.
Right.
Correct. But yes, a very valid point which you raised, that yes, you have to specify some details, that you need this, you don't need that, or what kind of feature you need in your database call when you are making any JDBC call or using JPA or ORM technology.
Right.
Great. Sure. So I think this is what we have for today. We covered infrastructure as code. We covered microservices architecture, and then we covered about some security needs. And then next time probably we'll cover containerization, serverless computing, DevOps, culture shift, what is observability. So there are some other characteristics, important characteristics of microservices architecture and cloud native application development. So containerization we already covered indirectly, because containers we already discussed also, like last time, how it's different from VM, and what is Docker, what is Kubernetes, and play around. I also advised you people to play around with Uber and Kubernetes. I'll share one resource on serverless computing. Serverless computing is another buzzword. I'll share you one of some good resources, some good readings on serverless computing, so that you can do a hands-on also. I have one tutorial on serverless code computing as well, and also an overview about how is it different from traditional computing. And security, you already know, it's very generic, but there are some components which is identity management, directory, what is user directory, Active Directory everyone would be aware of, because with Windows you would have used. And then cultural shift, there's a lot of things to be talk about in DevOps culture shift. There are various topics, but yes, we covered it briefly in infrastructure as code as well. And then we have to talk about observability, because since there are so many microservices running for your application, you should be aware of how is the health of each and every microservice. Because in monolithic servers, it's very easy to know whether your application is up and running, because you just have to check few places. Maybe you see that database is up, your application server is running, your web servers are running, that means your application's up. But in case of microservices, it will become very difficult. If someone asks, is your application up and running, as a developer, how will you answer? So the only way you can answer is you should have monitoring for each of these services, and then you, based on how is the response time, what's the state of the application, for how is the state of the service, and if you can get this information for each of the service, then you can tell that application is up and running, right? So this is all the content I have about this topic, which is about introduction to cloud native application development. And yes, to Madhup's point is, I'll ping you list of MicroProfile based server. We could not cover that because lack of time, but yes, I'll show you some microservices, MicroProfile frameworks, using which you can develop very easily microservices and deploy it on various containers in the coming sessions. But yes, there are various MicroProfile framework implementations.
Okay.
So, do everyone remember what is MicroProfile frameworks?
Yes, I remember.
Yeah, but tell for everyone, because maybe many would have missed that session about MicroProfile. What is MicroProfile?
Yeah. See, just I'm giving the example of the Spring Boot. Okay, someone has worked on the Spring Boot, and in case of the Spring Boot, what you have to do it, you have to write the code, you have to build the code, and then you have to deploy the code. And then you deploy the code, then you have to run the code, and then you will see that okay, what all outputs is coming from that, what all written code. But in case of the microprofile, you have to write the code and you have to run the code. You don't have to build the code. The build will happen autonomous, and run will also happen automatically. Means it is just you have to write a code. You don't have to think about all this thing. Okay, we have to. So that is actually the microprofile works.
Yeah. So see, very briefly I'll tell. MicroProfile framework is a framework which is similar to Spring Boot. But Spring Boot is a framework which can do a lot of many things. You can create a web MVC application, you can create microservices, you can create a monolithic application as well, you can create a lot of different kinds of application. But for microservices, it is not that very simple to do. Now, MicroProfile is another set of standard which is specifically for creating microservices. So developers felt that okay, although we have a lot of mature frameworks, but these mature frameworks requires a lot of effort to create a microservice, because for microservice you need so many things: observability, tracing, distributed tracing, and fault tolerance, and retry mechanisms, reliability, so many other stuff is there. So why not come up with a space standard and framework which is best suited for doing microservices development? So MicroProfile is a standard which is again a project under Eclipse Foundation. It's an open source project and it has various implementations. To see about the implementation of MicroProfile framework, you can visit the site microprofile.io, and in this you will find a list of products which are MicroProfile compatible. So there are two versions of MicroProfile. The latest one is MicroProfile 5.0, and if you look into the implementation of MicroProfile framework, you have various implementation. So Quarkus is one, Open Liberty is another one, and there are a few others also which are there. Right, so Open Liberty is there, Pyara Micro, that's another implementation. So there are many implementations of MicroProfile. Understood? So Madhu, this is enough to figure out,
Yeah.
right?
Yes, I'll
Or
figure it out.
very simple, you say just do a Google of MicroProfile implementations, right? So then you will get the list of MicroProfile compatible implementations, and which includes lot many servers. Tomcat Tommy, that's called there's a new version of Tomcat that is also MicroProfile standard, and I believe Spring Boot may also come sooner with MicroProfile implementation, compatible implementation. Wildfly is another. So there are many of the. So good thing about this MicroProfile framework was that many vendors have adapted it and they have implemented it. So all the concepts which we are discussing, they are covered within MicroProfile standard. We'll see that in upcoming sessions. Great. So that's all I have. Feel free to post any queries over the WhatsApp chat or wherever you want. No, I'll get back on that offline and right. So no problem if you have missed asking any questions this time. You can always ask. Feel free, and you keep the discussion going over the channel, over a WhatsApp group. Great.
Yes.
Thank you. Thanks, Arun.
Perfect. Slightly I went overtime today, maybe around 15 minutes, 15 more than 20 minutes. But yes, we had a great discussion. Thanks for everyone. Thanks everyone for attending and see you next time.
Thank you.
Thanks, Tarun. Thanks, everyone. Bye.
Okay, bye. Have a nice Sunday.
Thank you.
Thanks, Tarun. Thanks all.